second. So better start with easy questions. Every time you have an exam, for various reasons, make the most of the marks, make the most of your knowledge, get confidence anyway. So, this is about exam. But now, if we look at the first question, the main issue with that is to find out whether you know the difference between class variables and instance variables. You know how to work with class variables versus instance variables. And my way of dealing with that is X. Let's go and look at the class X. X is static, associated to the class. A is package level, is associated to instance variables. S2 is static, associated to the class. After we clarify this, we start from where? From the entry point in the program, which is main. And first statement in main is the declaration of a new object called created with the invocation of the constructor with argument 2. Remember, class variables, static. Class variable I initialize to value, default values. X is initialized to 0 because it's an end. As you can see, S and S2 are initialized to empty strings because the default value is null. Remember, null. But we want to do concatenation. So, if we look into invoking my class with argument 2, what we get inside the constructor, I will put X, S, and S2 after my class of 2 happens, right? What happens is S is increased by 2, right? So S gets the value 2. So this is class variable, this is instance variable, and this is class variable. This is important. So I is 2, X is incremented by 2. S is concatenated with X. In other words, S, which was empty, is concatenated with 2, so S gets the value string 2. S2, which was empty, is concatenated to X, so this gets the value 2 as well. Good, we got so far. And now we are out of my class 2, and we go to declare MC. So here we have the construction and MC, which is constructed with invoking my class 1. So I get the value 1. Whatever is class variable keeps the previous values. Whatever is instance variable is initialized in the constructor, right? So when I is 1, we go and invoke the constructor. X, which was class variable, is increased by 1. 2, it stays that, and is increased by 1, gets the value 3. Clear? S, which was instance variable, was initialized now to empty. Correct? And when you increment it with this X, you get, this is S. And S2, which was class variable, is this concatenated with that. In other words, we get the value 2, 3. Right? Right. Now, after this, we go to my class 4. I is 4, so X, which was class 3 plus 4, So we call my class 4 here. 3 plus 4 gives 7. S is instance variable. Empty concatenated with 4 gives you 4. And then what we have for S2, this value of S2 being class variable stays the same. And concatenated to 4, it's 2, 3, 4. We are done. 2, 3, 4. 2, 3, 7, right? It's X, sorry. You are right, it's X. 2, 3, 7. X is concatenated at the end. And then we have to print MCS. Okay, so we have to go here, MCS 3 concatenated with MCS2, which will be this, because it's class variable. Whenever it changes, it's changed for all objects. So be aware of this. This is the meaning of class variable, right? So the final answer is 3, 2, 3, 7. Okay, so you can think for this, you have something like 3 members, X, S, and S2. These are shared by all objects. Yes.
So X would now be 7 on all 3 as well, right?
Yes.
Yeah. Okay.
It's class variable. So when we have this MC is constructed with this. At the MC we have this, and 23 here. And after we call MC4, this comes MC4. This is 7 in MC. 237 is S2, 237. Because it shares between all variables. So, this notation, MCS2 is allowed, but it's misleading. The best way would be to say my class, right? And this is a recommended way, S2. To say this is associated to the class. If you can do this, prefer this notation over this notation. Right. And the last one, which is the easy one, was just to make sure that you understand the overloading, right? The first is output area 5.1, easy, right? 5.1 is an integer, so it calls the last constructor, 1 argument integer value. Now, if we pass a single string, we look at what we have in the parameters. No string exception is raised. So you get an exception raised for B. For C, you pass on a string and an integer, which means the second constructor is called, because we have a string and an int. And therefore, you get the string area is 49. Area 49, 7 times 5, 7. If you look at the body of the second constructor, right? Body of the second constructor. And the last D case you have string, integer, integer. So the first constructor is called. Yeah, so this was the easy one. Great. And we have covered this stuff in principle. We have covered. So here we talked about class variables, and they work similar in C++ and Java. So hopefully this clarifies other issues. After today, you can finish optional assignment. You have got marks for assignment 2 part 1, and you know what you have to fix there in order to submit a perfect solution for assignment, optional assignment, which is due 23rd. Be aware that marks for assignment 2 part 2 will come up on 20th of October because of workload issues and stuff like that. 20th of October, you can expect to get the marks for the A2 part 2. So do not wait for the mark to come up to decide whether you submit or not. Say, I will submit. Doesn't matter if it's worse or better than I want, you submit the Java assignment. It's optional, but it helps you to understand how to deal with Java programs, how to move from C++ to Java, and you don't have any extra help for that assignment. I will try, while I present things today, to point out what you have to do to solve that assignment. So, probably if you have read the handout, there is no extra help for this optional. But in the tutorial, you might clarify some things. So the tutorial this week will be held by Yukio, which knows very well this assignment and Java programming, so he might be willing to give you more hints. So, today, Java inheritance, and this is the last thing you have to know in order to solve your optional assignment. Optional assignment. So, if you have issues, you don't understand things here, look at the code, which I will try to run today. If not today, maybe tomorrow. Look at the code and read information on these topics and try to apply them. We are going through these topics, a lot of them. There is a large subset related to inheritance, subset of topics related to inheritance, which are common to C++ and Java, but there are differences. So, like in C++, when we derive classes, they inherit data members and methods. Constructors are not inherited. So you have to be aware of this and deal with that. But you will see system provides some default constructors, as we know. Visibility modifiers stay as in C++, 3 of them, but there are 4 levels. So there is a difference here. And because of this 4 level of visibility, we have a difference there. Using inheritance is quite extensive in Java, and as you can see, as compared to C++, we have deeper inheritance in Java because everything is derived from object in the end. Object is the root of all inheritance trees. And this is kind of different, of course. And as you can see here, 4 exceptions, for example, which come in different flavor. Runtime exception is derived from exceptions, which is coming from throwable, which is coming from derived from object. But we will see that there are 3 types of classes in Java. normal classes, abstract classes, and interfaces, and they are different. The interface type is something which we don't have in C++, is achieved using other procedures. Okay. So the visibility levels decide who is available to what. And if we look at this small table, if we have a public method or field in a class that is available to the members of the class, available to the package where the class is, everyone in the package has access, available to the derived classes, subclasses, and available to the outside world. So public is giving access to everything, of course, with import the file, which whatever is required. Protected, like in C++, okay, what did happen? Okay. Protected is a little bit more restrictive. Give access to these three types, everything in the class, in the package, in the subclass, but not to the outside world. If you put no modifier, the default modifier, as you remember in C++ is private, but in Java it has package level. If you put nothing, of course, whatever you define with no visibility, you don't put private, public, or protected. You leave it empty. Just put the type. Then everyone in the class itself can work with that notion, and everyone in the package. But derived classes are not allowed direct access. And private is most restrictive. So this is the 4 level of visibility. The only difference is just package level. And here we have a simple example. And you will have to create some classes like this. Employee class, which will be a base class like this. Maybe an abstract class when we talk about abstract classes. So as you can see here, we go back to the hierarchy of shapes, circles, rectangles, which are considered 2-dimensional shape. And our class, which will be the base class from which we inherit data, comes with 2 protected data members, coordinate of a point. They are protected, as you can see, because we want them available in the derived classes. It comes with a constructor, public, accessible to everyone. As you know, protected is accessible to class itself, package, and the derived class. And then print. Now print, as you can see, has no visibility specifier, therefore package classes. Classes in the same directory, part of the same package, have access to them. Now, this is a syntax and it's different for what we have seen before, right? In Java, you have to use the word extends. Be aware, you can extend only classes, not interfaces, you will see. For interfaces, we have implements, so there are 2 ways of derivation. Our circle, which is a type of a shape, comes with its new data member. It inherits the coordinates from there for the center of the circle. And then the constructor, as you expect, and overriding a print method, right? We give a new meaning to print. So this is override. Available in Java as well, no arguments, so you have identical prototype for overriding. Java has single inheritance. You can't have multiple parents, and if you look at how various classes are designed, you will see that each class has a single parent. Single parent. Right. Now, everything except primitive types are objects, and because of that, the people designing the language were thinking that it was a good idea to have a root for all classes which are defined. Because in that class they put some method provided most likely by all derived classes. For example, how to do deep copying, because when you use assignment for objects, you are working with references, you are working with pointers, it's not deep copying. So therefore, you can implement this method which is clone, make a deep copy. It depends on what deep copy means for different classes. If it's an abstract class, what does it mean to make a deep copy? If it's a concrete class, it means a different thing, right? Equals, test whether two objects are equal, as opposed to the symbol equal, which tests for identical pointers. You might want to test whether two objects have same content, like strings, for example. You might have different objects defined with new everyone. A circle, for example, circle 1, which has x 1.3 and 2.9, and radius 10, and a circle 2. So this is circle 1, circle 2. And it was defined with new invocation to constructor, but you might have something like this. If you try to check S1 equals S2, most likely you get false, because they look, is S1 pointing to the same direction? No. To the same memory? No. So in order to test the content, you have to use equal. But if you design your type, you have to implement them. So normally you implement for circle type, what does it mean to be equal, and you check C1 equals C2, and this will return true. This will return false. So as you can see, there are two types of equality. For your assignment, you don't have to worry about this and this, but you will have to implement toString. toString is a method which is declared in the object class, which is an abstract class, but because it's there, you have the prototype available for you to write code. It takes no argument and returns the string representation of the object. And if you look at this example, all it does returns concatenation. If you want to put some string there, that's fine, but normally you return for a circle, you might say circle plus and add mx, my, and m radius, because you want to specify what is the center and what is the radius. For your assignment, you have to look at how you implement it, print in your individual classes. Now, as you can see, this is a prototype, and each of your class for your assignment have to have this. In other words, you overload the toString method. And C++11 has a method called to_string. It doesn't work in Sci-T, but if you use CPP shell, it's available. Anyway, and as you can see, it always has to be public and return a string. Return a string. Very simple concatenation. And you will see how to call the parent class toString method, for example. Overriding is where we have seen print in the first example with the circle and the shape. And there is no extra syntax, but no extra syntax because Java compiler use dynamic binding. Everything is a reference, and decide what print to be called based on the object used for initialization. So there are not two steps in Java to provide polymorphism. By default, polymorphism is part of Java behavior. Okay. Everything is a reference, and therefore polymorphism is the default behavior of Java. So there are no special keywords for dynamic or late binding. And there are this one simple rule if you want. Private, static, or final method use static binding. You never can make them dynamic. So if a method is private, associated to the class, or non-changeable in the derived classes, they are static, assessed as a compilation time. Nope. And therefore, overridden is not allowed on this type. Static, final, or private. All other methods in your classes are dynamic. Simple. Not so confusing in C++, where you don't know the base class had a virtual function or not, pure virtual or not. We will see. It's a style issue. Use a recommendation for the compiler to help you check the correctness of the code. So as you will see here, as the symbol you use in the email address, followed by override, helps the compiler to check that there is a method in the base class with the same name, and you are indeed providing overriding. It's not a must, it's not part of the required syntax, but it's a good style approach. So whenever you have a method which is provided first in the base class and you have a different behavior there, it's good to put this. And this is part of a whole package to talk about how to write comments. Comments in Java are provided in what is called annotation, coming with various conventions, how to write the authors of, how to write the parameters. We don't get there, but if you go here, form of metadata is not normal syntax, but provides data about a program. Okay. Information for the compiler, runtime processing, so it's a large topic. We are not going to go into details, but this makes a part of the documentation for Java, which provides very nice documentation online. Now, constructors in a hierarchy. We don't have initializer list in Java, so how do you call the base class constructor in the derived class, because they are not inherited? Okay. And there is this super keyword, which is used only in methods. Constructors are methods themselves, and it has to be the first invocation in the constructor. This is used to explicitly call the constructor of the parent, no more, no less, the base class, right? And the base class calls its base class constructor, and so on and so forth, till the object constructor. But this, as you can see, says each class is responsible to set up the good initialization of its base class, no more. You don't have to look up in the hierarchy. So if we look at the shape and circle, as you can see, we have the constructor for shape, reusing code. We don't have to rewrite this. We just, in the circle constructor, invoke super. Remember, it's the first statement in the constructor, and is taking one argument for the first data member initialization, and the second argument, this y, is provided as the second argument. As it happens, these names are repeated, but you can say A, B, and C here. So I call super with A and B, all right? So this is how you set the problem, resolve the problem of base class constructor, and in a similar way, you can use them in methods. So, as you can see here, in case you don't define your, or you don't invoke your super, the constructor of your base class, the compiler provide an invocation to super, which I have a simple example for next lecture. Does not work always as you expect them, because it might have data not initialized at the time of calling. What it does very superficial job. So it's good to invoke the base class constructor with super yourself. Right. This and super has to be the first one. And you can use this super to invoke method in the base class. Right? When we override, when we have overridden print, we don't want to repeat the code about this, and we would like to use information which was already written. So how you call it, again, it has to be first, you call super with this membership operator and invoke print. In C++, you use class name scope operator, right? Right, so these are different. And for your assignment, you have to use this. For all derived classes, when you write your constructors, make sure that you have super. And when you write your default constructor, you use super for default constructor base class constructor. When you write your constructor for passing arguments, be aware you can't pass arguments with constant values like in C++. You have to declare your variable and initialize them in your classes straight away. Like we have some example. And then when you want in your derived class method to reuse code from the base class, you have to use super. Okay? Super to string will be used extensively in your classes. Right, so this is the basic thing about concrete classes. And now we go to the next level, talking about abstraction. Abstract classes in Java come with their own syntax. Right. And they are equivalent to what we had when we had pure virtual function in our classes. In Java, you have to use abstract keyword before class. You can have implementation for all your method in your abstract class, which is unlikely. But you still can put abstract there and say this class can't be instantiated because it's like in C++. The other rule is if you have one abstract method in your class, you have to put abstract in your class type. Okay? So if you have at least one abstract method like here, you just put the keyword and leave no implementation. Right? It's a little bit clearer as compared to C++, because as you will see, every class which is, this being abstract can't be implemented. You can't declare object of type shape and say new shape and provide some, you can't invoke that constructor. You have to use initialization from derived types. We will see in a second how to work with that. In a sense, you work like you work with abstract classes from C++. So, what happens, for example, for the object class, that is an abstract class which has a lot of clone, prototype. It's an abstract. It's not an abstract thing. It has a very basic thing. Clone, it's abstract. Then toString, because you don't have any method. How can you put toString for an object? You don't know what the object is about. But then there are classes derived from object which can implement them. Every concrete class must provide implementation for every abstract method inherited from an abstract class. So, because we can go ahead without providing implementation to string or to clone, you can think that there are levels between that object class and our class, which makes possible to waive this condition. That's why I was a little bit confused at the moment. Every concrete class must provide implementation. Otherwise, it has to be declared abstract. It has to be declared abstract. And this is kind of different to C++. If you have a pure virtual method in your base class, you don't have to specify anything in your derived class. It stays virtual, but the user might not know. So this was a little bit of a confusion. whenever you look at these abstract classes, try to compare them with what's happening in C++. We have seen that abstract classes can provide some implementation for its method, but interfaces are not allowed to provide any implementation. So they are a different type of classes. They are called using this keyword, and classes can implement more than one interface. This is what is equivalent to multiple inheritance in C++. Because there is no implementation of method in interfaces, there is no diamond problem as we have it in C++. So a class in Java can extend at most one base class, abstract or non-abstract, but one class, and can implement more than one interfaces. So be aware of this. By default, no matter what you put in your interfaces, the methods are public and abstract. Public and abstract. Doesn't matter what you write for your code. And here we have a simple example, and we will finish with this. Here we have an interface called drawable. And what it does, it just provides a prototype of a method. An object is, so what we put in place is enforce a behavior to be implemented in the future. Whatever relies to graphics has to provide some drawability features. This is what the designer has in mind. And as you can see, interface keyword, here we have a base class shape. Circle will extend shape and implement that interface. As soon as it pledges to implement something, it can implement more than one interface, as I said. It has to provide bodies. So for draw, it has to provide some behavior here. Code. What does it mean to draw? Display X, MX, display MY, display rep, radius, whatever. Right. So if you have worked with Java, probably you have seen that many events implements mouse down, implements mouse up. What happens when things do like that? Polymorphism is simple. All objects stored dynamically. There is no confusion between reference pointers and actual objects. Okay? So, we will stop here, 25. You have all the notions you need in order to solve your assignment. What is different compared to C++, to your assignment for C++, is that you have to use toString to work with printing, and you have to implement toString, you have to use super. So other methods are quite simple and similar to C++. Yes?
Do we have to do everything not in line again? Not in line.
In Java, there is no notion not in line. Everything is inside the class. Everything is inside the class. You can't implement functions outside. Everything is in line, if you want, right? So everything will be, you write your class, and then data member, this is a data member for your class, and method, close the class, and so on and so forth. And yeah, start working on that, and good luck. And we will continue tomorrow from here, and try to run the program. put together. Thank you for coming. And good luck with your work.